Okay, video number 2 about the required practical in the waves topic. There are 2 methods that you need to be familiar with. In method 1, a wave is created in a piece of string or a piece of elastic with a vibrating device, and the string is stretched over a pulley and held in place by a weight. The second method involves using a ripple tank, which is full of water, with an oscillating motor causing a wooden rod to bounce up and down, creating waves. In both methods, you need to make measurements and relate those to the wave equation, where the speed of a wave is equal to frequency multiplied by wavelength. So make sure you can describe how those quantities are measured in each of the methods. You can use the Focus On app on your iPad to refresh your memory about doing these experiments. And if we look at these in turn, method number 1 is using a signal generator to provide a certain frequency, so we can measure the frequency by reading off the value on the signal generator, and the vibrator is causing an up and down oscillation, which is making a transverse wave in this piece of string. Okay, by changing the frequency, you get to certain positions where what's called a standing wave is produced. And if we slow this down, you can see what that means. So in this length of string, which is 2 meters long, there's 1 up and 1 down. So this equates to 1 wavelength. We've got the frequency from the signal generator. We've measured the wavelengths with a meter ruler, and so we can use those 2 numbers to calculate the speed of this wave. Change the frequency on the signal generator until the next standing wave is produced. Here you can see there's 1.5 wavelengths. And at regular intervals, a standing wave is produced, and at that point you can take the frequency and the wavelength, multiply them together to get the speed. So here we've got 2, if we slow this down, we've got 2 complete waves in 2 meters, so the wavelength is 1 meter. Read the frequency, take the wavelength in meters, and multiply them together to get the velocity of the wave. The second method with water can also be used, and in this example, a stroboscope, a flashing light, is being used to measure the frequency of waves. Okay, so in this example, we shine a light through the tank of water. The motor is causing the dibber to dib up and down and produce a wave, and we could measure the wavelength. Remember, a more accurate way of measuring it would be to measure 10 waves or 5 waves and work out an average. The stroboscope here will cause the wave to appear to be stationary when it is flashing at the same frequency as the wave, like this. So here we could count wave fronts: 1, 2, 3, 4, 5, 6, measure how long they are, and divide by the number of waves you've counted to find the wavelength. The frequency is the frequency of the strobe, but if you didn't have a strobe, then you could count how many waves pass a point in a second. But obviously 1 second is too difficult to time, so you'd count how many waves perhaps that there were in 30 seconds or a minute and divide in order to get an average frequency.